is where it gets a little bit tricky. We've got to keep track of our information. So you're going to make two piles of information here. I'm going to make a pile of information for iron, and I'm going to make a pile of information for, is it water? All right, iron. So we have a mass of 15 kilograms, and its temperature initial is 98 degrees. Oh, somebody's at Timberlake. Okay. And that's in Celsius. And it's quenched. Quenching is a process where you heat iron up really fast, you bend it and you work it around, and then you jam it back in to water to cool it down really fast. When you do that, you're going through a process that allows all the grains in the metal to line up, and it makes the metal stronger, more durable. Okay? That's the idea. Let's see. So essentially what you're doing is changing the properties. Okay, 40 kilograms of water. At an initial temperature of 20 degrees Celsius, is that correct? Okay. Now, the specific heat, or the ability of iron to take in heat, is 450 joules per kilogram dot Celsius. Okay. And for water, it's going to be 4,180 joules per kilogram. Is that all the information we have at our disposal?
Yes.
Okay. Now, okay, our equation to go for this is,
Wait, what's the unknown?
what is the unknown? What are we looking for? What's it asking for? It is asking for T final, right? Because they should theoretically, if they're locked in a system and energy can't escape, they should both come to the same final temperature. Okay? So the equation that you want to use is Q of iron plus Q of water is going to equal 0. Okay? And how that works out is that no matter how much heat exchanges between the two of them, does any heat escape? No, not at all. Okay? All right, now, again, we'll go MC delta T of iron plus MC delta T of water is equal to 0. Okay, I have information, I'm going to take the T's and I'm going to spread them out because I'm looking for T final, right? So it's going to be MC T final minus T initial plus, and that's for iron, MC delta T, or not delta T, we'll just go T final minus T initial, and that's for water, and that's equal to 0. Okay, now I can put some numbers in. I already know this one, and I can distribute across. When I put my numbers in, I can distribute across, and I'll have terms here that will be negative that I can push over here. Make sense? Okay, so it was 15 times 480 or 450? Okay, and that is T final minus, what was my initial temperature, 98? Okay, plus, this one's 40 times 4180, is that correct? Yes. T final minus 20, okay? So what's 15 times 450? 6750. Okay, times 98. 50 TF minus
Oh, is that,
6750 times 98.
okay, that's, 661,500.
661,500. Okay. Just no. Leave that alone for right now. Okay. And then, so this is just my water, right? Or I'm sorry, my iron. Right there. What's that?
You did 6,750 times.
Yeah, so 15 times 450 is 6750. Okay, kudos, Greg. All right, and that times this is 6750 times T final, and then this distributed over here is 661,500. Okay. All right, same thing over here. 40 times 4180. Somebody double check me, but I have 167,200. So plus 167,200 T final minus, and then that times 20. 3,344,000. Right? And this all equals 0. Again, this is my water right here. So I'm still just keeping track of things. All right? Now, taking it back to Algebra 1, but then you guys didn't have Algebra 1, taking it back to like Advanced Math 1A Accelerated Undergrad Geometrical Processes 3.5B. Whatever math class that is that you guys had, okay? I can do, what should I do next to solve this problem?
Combine like terms.
Okay, combine like terms, so I can work with these guys and I can separate these guys. Which one should I send to the other side? I'll go ahead and send these over. Why these?
I don't have a variable.
Negative, right? I can make my life easier, just push them to the other side by adding them across. Okay? So I'll go ahead and do that over there. All right, so 3,344,000 plus 661,500 is 4,005,500. Can anyone confirm or deny that?
That's correct.
Right.
6750 plus 167,200. 173,950 T final. Is that?
Mm-hmm.
So good so far? Okay, so then T final. Oh, I hope this works out. Otherwise, it's what, 20 minutes down the drain? Okay, so I'm going to divide out on this side because it's a multiplication, so I have to divide out, remembering my algebra. Here we could add and subtract out because we didn't have things multiplied together. 4, 0, 0, 5, 5, 0, divided by 1, 7, 3, 9, 5, 0. I get 23.03, we'll call it, degrees Celsius. Is that reasonable?